So what we want to do in these last two sections are solve some trigonometric equations, okay? So we know all about trig functions, we know all about inverse functions now, so we're trying to solve these equations. And like anything else or any other time, we would try to isolate the variable term, okay? Or whatever function includes our variable. So for instance, in A, I've got 4 cosine squared theta minus 3 equals 0. So I'm going to move the 3 to the other side, right, by adding 3 to both sides. And then I can divide both sides by 4. Okay? So we got the function that has our variable, we got it on one side. All right, then we take the square root of both sides. So cosine theta, if I take the square root of both sides, is going to equal what? Root 3 over 2 plus or minus, right? Both of those are our solutions. Okay, cosine theta root 3 over 2. Cosine theta equals plus or minus root 3 over 2. So now we need to ask ourselves, where does that happen? We need to find every place where this happens between 0 and 2 pi. We need to find where cosine theta is equal to root 3 over 2. We need to find where cosine theta is equal to negative root 3 over 2. How many answers should we have altogether? How many? I think I heard it earlier. What'd you say? 4, right? This is the magic of the reference angle. The reference angle. Remember when we talked about reference angles, I told you reference angles are the most important thing. They're the most important tool because they take your quadrant 1 knowledge and extend it around that unit circle. Okay, so let's see what we get. When I say cosine, I need to know where cosine theta is equal to root 3 over 2. Well, that happens when theta is equal to what? Pi over 6, right? Everybody remember that? Cosine of 30 degrees is pi over 6. And we get square root 3 over 2 when we take cosine of it, right? Well, also over here, the reference angle, pi over 6, when I take cosine of it, is either going to give me plus or minus root 3 over 2. Everywhere where I have a reference of pi over 6. Does this look familiar? Y'all remember all of this? Everywhere where I have a reference of pi over 6, it's either going to be plus or minus root 3 over 2 when I take the cosine of it. Okay, in quadrant 1 is positive. In quadrant 2, we're talking about cosine. So in quadrant 2 is positive. I'm sorry, it's negative. In quadrant 3, it's negative. And over here, it's positive. Okay, does everybody understand how I use the reference angle to find those spots? Okay, so then the only question left is, what are those actual angles? So, of course, we already said theta equals pi over 6 in quadrant 1. In quadrant 2, it's going to be 5 pi over 6, right? Because we'll say the reference angle is pi over 6. So if I do pi minus pi over 6, we get 5 pi over 6. Okay? Then I got a reference of pi over 6 here. So we get what? 7 pi over 6. Very good. And then reference of pi over 6 here, 11 pi over 6. And so there it is.
So if we see this on the test, you want all?
Every solution between 0 and 2 pi. Normally, we'll be looking for every solution between 0 and 2 pi. A little bit later, we will look at finding all solutions, and we'll come up with kind of a formula for the solutions. But right now, we'll just limit it to 0 and 2 pi. Okay? Questions about that? All right, that went back and did a little bit of review, but you got to understand that so that you can find all of these answers.
So we actually memorize the unit circle?
No,
Okay.
no, I didn't say memorize the unit circle. I said understand reference angles. Okay, but if you don't understand reference angles, you need to memorize the unit circle. All right, memorizing the unit circle though is going to leave you with some gaps in your knowledge. You need to really understand reference angles and how they work. Okay. All right. But I've been saying for a while, we have to know these values backwards and forwards. And that's true, quite literally. Okay. Okay. So we got 3 root 2 cosine theta plus 2 equals negative 1. So again, I'm going to try to get the variable term on a side by itself. So we get 3 root 2 cosine theta equals negative 3. I subtract 2 from both sides. Okay, then I'm going to do what? Divide both sides by 3 root 2. So negative 3 over 3 root 2. Okay, so we get cosine theta equals negative 1 over root 2. Okay, well, that should look familiar to you, right? We're talking about cosine theta equal to what? Okay, well, theta would be pi over 4, right? This is minus root 2 over 2. So you should be thinking about a reference angle of pi over 4. Okay, and in this case, we just need to know where cosine theta is equal to negative root 2 over 2. So cosine is negative in quadrants what? 2 and 3. Okay, so I need reference angles of pi over 4 in these two quadrants. So that gives me theta equals what? 3 pi over 4 and 5 pi over 4. Very good. Okay, questions about that? Any questions?
So, right at the end, like, can you point out how you found the reference angle one more time?
Because when I see square root 2 over 2, I think 45 degrees automatically, pi over 4. So, I kind of verified, yes, cosine of pi over 4 is root 2 over 2. But I need to know where we get negative root 2 over 2. And so I thought about where's cosine negative. Cosine is negative in quadrants 2 and 3. And I used the reference angle of pi over 4 in those two quadrants. All right, to find 3 pi over 4 and 5 pi over 4. Okay? All right, very good. Okay, let's look at this one. We've got cosine of theta over 3 minus pi over 4 equals 1/2. Okay, this problem you could be tempted to overthink, but let's just look at this for right now as one big giant angle. Let's call it alpha. Okay, so if I was saying cosine of alpha equals 1/2, we already know where that happens, right? Where is cosine equal to 1/2? Where? 60 degrees, so that's pi over 3, right? And where else? Which other quadrant do we need to look in? Fourth quadrant, and it's going to have a reference of pi over 3. So what would this angle be? What is it? Mm-mm. 5 pi over 3, right? 2 pi would be 6 pi over 3, right? So if we subtract pi over 3, we get 5 pi over 3. Okay? So what I'm going to say then is that theta over 3 minus pi over 4, could be equal to pi over 3, and we can solve that for theta, or theta over 3 minus pi over 4 equals 5 pi over 3. Okay, and then solve for theta from there. Okay, everybody understand why we set that up that way? Okay, we're looking for a line of an expression that we have here such that it's equal to 1/2. Okay, well, we know that this expression has to be equal to the angles where cosine of alpha is equal to 1/2. And so we found two angles, 5 pi over 3 and 5 pi over 3. Now we can solve from there. Okay, so to solve this, I'm going to multiply both sides by the least common denominator, which would be what? 12. Okay, so multiply by 12 on both sides. So we get 12 pi, or 12 theta over 3 is 4 theta minus 3 pi equals 4 pi. Okay, or 4 theta equals, if I add 3 pi to both sides, we get what? 7 pi. And so theta equals 7 pi over 4. Okay, that'd be one solution. All right, if we let theta be 7 pi over 4 up here, then that will give us a true statement. Okay, and then over here, do the same thing. Multiply both sides by 12. And so we get 4 theta minus 3 pi equals 20 pi. Okay, 4 theta equals 23 pi. Theta equals 23 pi over 4. Okay, now with this one, we need to be a little careful because we do want our answers to be between 0 and 2 pi, right? And this is way beyond 2 pi. So how can I find the correct answer for that one? Or we're not in degrees, so subtract off what? 8 pi over 4, right? Multiples of 8 pi over 4. We need to subtract off 2 pi, okay? So I think I can do it 2 times. I'm going to subtract off 16 pi over 4. That's 2 full revolutions, right? And so that's going to leave me with same answer, 7 pi over 4. Coincidence, okay? So don't make a general assumption there. We have one answer, theta equals 7 pi over 4. Questions about that? Any questions? Okay, very good. All right, so here's what I was just mentioning about coming up with a general formula, okay? Because we're talking about real numbers, right? They go on and on and on forever. We couldn't list all of the solutions to these equations because they're infinitely many, right? We talked about the periodic properties of our functions. So we want to come up with a more general solution, okay? So it says solve each equation, give a general formula for all the solutions, and then list 6 solutions. So we got tangent theta equals 1. Okay, well, we already know where that happens. Where does it happen? Okay, thanks. Where's tangent theta equal to 1? Okay, tangent of what angle equals 1? 45 degrees, or in radians, it would be pi over 4. Okay, so also, though, where else? Tangent is positive in which quadrants? 1 and 3. Very good. So I need a reference of pi over 4 right here. That's going to be what? 5 pi over 4. Very good. Okay. So pi over 4, 5 pi over 4. If we were just doing 0 to 2 pi, then those would be our answers. Okay, but we know tangent has a period of what? Pi, right? So every pi, we're going to come back to something that's coterminal and would be a solution. We already see that because we went from pi over 4 to 5 pi over 4, right? The difference is just what? Pi, right? The next answer would be 9 pi over 4, and then 13 pi over 4. So how do we write a general formula for that? I'm going to say theta equals pi over 4 plus k pi, where k is an integer. Okay, that's how we write the general solution. So as long as you put in an integer k, an integer for k, then you'll get a solution to tangent theta equals 1. Okay, so they ask us to list 6 solutions. We've already got pi over 4, 5 pi over 4. Okay, that's when we put in 1. If we put in 2, we're going to get 9 pi over 4, and then 13 pi over 4, 17 pi over 4, and 21 pi over 4. Okay, those would be 6 solutions, but they would go on and on and on, infinitely many. Questions about that? Okay. All right. Okay, what about B? We've got sine 2 theta equals -1. Okay, sine 2 theta equals -1. Well, I'm going to treat this one kind of like I did the other. For now, just kind of ignore the 2 theta and just treat this like some big angle alpha. Okay, and ask myself, where is sine of alpha equal to -1? For what angle alpha is sine equal to -1? It's not pi over 2. It's not 2 pi. 3 pi over 2. Okay? So, but we're not really talking about alpha. We're talking about 2 theta. 2 theta equals 3 pi over 2. All right? Does everybody understand why we said that? Okay? Well, when you think about sine theta, at this point we have coordinates 0, -1. Remember, on the unit circle, we can think of this as cosine and sine, right? So sine of 3 pi over 2 is -1, okay? But here's our angle. Our angle's not just alpha, it's 2 theta. So we need 2 theta to equal 3 pi over 2. Does that make a little sense? Okay, so then we divide both sides by 2. If I'm dividing by 2, I'm going to write this out since we had discussion about this. That's the same thing as multiplying by the reciprocal of whatever it is I'm dividing by. So times 1/2. So we get 3 pi over 4. Theta equals 3 pi over 4. Okay. Now, we're not quite done because we need a general formula, right? So at this point, I think about, let's see, and actually I need to go back a step. Yes, let's go back a step. Okay. This isn't wrong, but right here, I need to go ahead and start thinking about how often will I come back to this point, right? And so the period for sine is what? 2 pi, right? So we're going to say plus 2 pi k. All right, where k is an integer. K is pretty commonly used to represent an integer. All right, if I go around 2 pi, then I come back to something that's coterminal. If I go 2 pi 2 times, we come back to something that's coterminal, and so forth and so on. So don't forget 3 pi over 4, because we still should get that as one solution. But so now I solve for theta. Okay, and so we divide both sides by 2. Theta equals 3 pi over 2 plus 2 pi k over 2, or 3 pi over 4 plus k pi. All right, so that would be our answer. All right, so how do we get solutions? Okay, well, if k is equal to 1, that's what we're thinking, 4 pi over 4, right? So that's going to be, well, first of all, if it's equal to 0, we get 3 pi over 4. If it's equal to 1, 7 pi over 4. If it's equal to 2, we get 11 pi over 4, 15 pi over 4, 19 pi over 4, and 23 pi over 4. Okay, questions about that? Okay. All right, very good. Okay, now we want to use the calculator to solve each equation. Okay. Now the thing about using the calculator, you might feel really happy about that, but the thing about using the calculator is it's only going to give me one answer when we use sine inverse. Okay. But looking at these equations and considering, the discussion that we just had, in example A and in example B, I know I should have how many solutions between 0 and 2 pi? Not 4, just 2, right? We had 4 when it was plus and minus, okay? But this is just minus, so we're going to have 2 solutions, right? But when I use sine inverse on my calculator, it's only going to give me one solution. So what do you think I'm going to use to find the other solution? Not a formula, something else. My favorite thing, reference angles. Okay, reference angles. We'll use the reference angle to find the other solution. Okay. All right. So we got sine theta equals negative 0.2. Now, again, just going back over what we just talked about, I know I should have solutions for this in which quadrants? Which ones? I just didn't hear you. Which ones? 3, not 3 and 4, but yeah, 3 and 4. Sorry. Okay, because sine is negative in quadrants 3 and 4. Okay, but if I use sine inverse, okay, it's going to give me an answer in quadrant 4, right? Because sine inverse is defined from minus pi over 2 to pi over 2. Okay, so that's fine. I just need to keep that in mind. Let me get my calculator. Does everybody understand why we're going to do sine inverse? Okay, this is the same thing as saying theta equals sine inverse of minus 0.2. Okay, theta equals sine inverse of negative 0.2. Okay, and so from here, I'm I'm going to go on the calculator. I'm in radian mode, so I'm going to do second sine inverse of negative zero point 0.2. It gives me minus 0.201. Okay. All right, I'm going to store that. Actually, I'm going to store negative that, so it'll be positive. Negative second answer. Oops, sorry. I'm going to store it in alpha A. Oh, no, I can't do that. Let's see. Delete alpha A. Let's see if it'll let me do that. Okay, good. So I made it positive in my variable. All right. That'll just help. Well, um, I'm going to need both the positive and the negative. I'm kind of jumping ahead and thinking about my reference angle. Reference angles are positive, so that's why I made it positive. So far, does that kind of make sense? I'm going to talk more about it. We got that negative 0.20, what was it? 13. Okay, so dot, dot, dot. All right. I got to do two things with that. First of all, I need to find this angle. So to get that, how do we get it? To figure out what this angle is. Pi plus the reference angle. That gives me the solution over here. Does that make sense? Okay, here's my reference angle that I got from that answer. So I want to know what my actual angle is. It's going to be pi plus 0.201. Okay, so on the calculator, I just need to add pi to this one. Okay, we get 3.342. 3.343. Everybody okay with that? All right, and then we had an answer over here that was negative 0.201. Well, that's not going to work for me because we want solutions where? Where do they tell us to put our solutions? Between 0 and 2 pi. This is negative. It's not between 0 and 2 pi. So how can I get an equivalent or a coterminal angle between 0 and 2 pi? I just need to do what? Add 2 pi, right? Add 2 pi to the negative 0.201 number. Okay? So 2 pi plus negative alpha A. We get 6.08. Okay. All right, so those are my two answers. Theta equals 3.43, 3.343, and 6.08. Okay, questions about this? Okay, any questions? Okay, all right, let's try another one. Okay, we got 4 cotangent theta equals negative 5. All right. So the first thing I want to kind of think about is in which quadrants I'm going to have solutions for this equation. In which quadrants will we have our solutions? 2 and 4. All right, does everybody understand why we said that 2 and 4? Right, it's cotangent is negative in 2 and 4. Okay, so I'm going to think about that first. Okay, cotangent is negative in 2 and 4. Okay. Now I need to, if I'm going to do this on the calculator, I'm going to have to convert this to tangent. right? So we're going to say cotangent theta equals -5/4, or tangent theta equals what? -4/5. Okay? And so I can say theta equals tan inverse of -4/5. Okay? All right, so on my calculator, I'm going to do tan inverse of -4/5. Okay, it gives me some answer, -0.67. Okay, and because basically my reference angle is going to be 0.67. Okay, -0.674. Let's leave that there. Okay, -0.67 is what we get. How can I get the appropriate answers? How can I get back to the other side? Just add pi, right? Because remember the period for tangent is pi. So if I add pi, that's going to give me my answer in my second quadrant. And then to get an appropriate answer in the fourth quadrant, I need to add pi again, right? This is not fine because it's negative. And we need something between 0 and +2 pi. Okay, so I'm going to add pi. And I'm going to add pi again. And so my two answers are 2.466 roughly and 5.608. Okay, those are the two answers.